Next, we're going to look at arithmetic with complex numbers. We're going to be focusing on adding, subtracting, and multiplying them. We're not going to look at dividing complex numbers right now because that's used a little bit less often. We will look at it later if we end up needing it in any of the problems that we do in the future. But for right now, just adding, subtracting, and multiplying. Adding and subtracting them is the easiest. If we look at an addition problem, for example, 3 minus 5i plus 2 plus 7i, we can add these two complex numbers just like we would add two polynomials by combining like terms. The parentheses here don't have any mathematical necessity. They're just there to say this is the first complex number and this is the second. So we can remove them without changing the value of the expression. It's the same if we write it like this. And then we can just combine like terms. We can combine the real parts and the imaginary parts. So for the real parts, 3 plus 2 gives us 5. And then the imaginary parts, negative 5i plus 7i is 2i. And we end up with 5 plus 2i as our answer. We can almost treat the I as a variable. I want to be clear that it's not a variable. It represents a very particular number, the square root of negative 1. However, when we are adding and subtracting complex numbers, it works very similarly to how a variable would as far as like terms go. So that is an addition problem. Let's take a look at a subtraction problem. Let's look at 4 minus the square root of negative 36 minus negative 2 plus the square root of negative 81. Now here we have to do a little bit of work to put these in standard form for complex numbers. We've got two square roots of negatives that we have to evaluate. So first, let's look at the square root of negative 36. The square root of 36 would be 6, but because there's that negative in there, we know it's going to be 6i. And then in the second one, the square root of 81 is 9, but because it's negative 81, it's going to be 9i. So rewriting these numbers as complex numbers in the standard form, a plus bi, this becomes 4 minus 6i minus the quantity, negative 2 plus 9i. Now here, we can't just remove the parentheses because there's this subtraction that needs to be distributed to each of the terms in the second complex number. So we can get rid of the first parentheses, 4 minus 6i, but to get rid of the second, we're going to have to distribute that subtraction. So when we subtract negative 2, that's the same as adding 2. And then when we subtract 9i, that's going to be minus 9i. And now that we've gotten rid of the parentheses, we can combine like terms again. Combining the real parts, 4 plus 2 gives us 6. And then combining the imaginary parts, negative 6i minus 9i is negative 15i. It's not that much more difficult than adding complex numbers. We just have to distribute that subtraction to both of the terms in the complex number that's being subtracted. Now, multiplying complex numbers ends up being a little bit more intricate here. Let's look at some examples. Let's look at 6i times 2 plus 9i. Now here, your intuition might be telling you that we need to distribute that 6i, and in this case, you're absolutely correct. 6i times 2 gives us 12i, plus 6i times 9i gives us 54i squared. This is because 6 times 9 is 54, and I times I is I squared. However, we cannot just leave this I squared like this, because there is a simpler way to write I squared. Let's remember I is the square root of -1. Now, I'm going to give you a fact that might blow your mind right now. This means that I squared is equal to -1. Now, why is this the case? Well, we know, for example, 5 is the square root of 25. This is because 5 squared equals 25. And 3 is the square root of 9. This is because 3 squared equals 9. Whenever something is the square root of something else, that's because if we square it, we end up with that something else. So I is the square root of -1. That means if we square I, we end up with -1. So this ends up being very important. And this is where our treatment of I is actually different from just treating it as a variable. Because if I was a variable and we had distributed this 6i here, we would be done. We would have a polynomial. However, this is a complex number, and we have to be able to deal with this I squared. And so here we can replace I squared with -1. So this is 12i plus 54 times -1. Now 54 times -1 is -54. And so as a complex number, this is 12i minus 54. If we want to write it in standard form, usually we put the real part first and the imaginary part second. So we can switch the order and write this as -54 plus 12i. Whenever we're doing any arithmetic with complex numbers, we should be able to write the final answer in standard form, starting with the real part and then ending with the imaginary part. So we can't leave this as 54i squared. Let's look at one more example of a multiplication of complex numbers. Let's take a look at 2 plus 3i times 3 minus 2i. What does your intuition tell you about how we can multiply these? Well, this almost looks like a binomial times a binomial, because each of these has 2 terms. And we know that when we have a binomial times a binomial, we can multiply it out by foiling. So let's do that. The product of the first terms, 2 times 3, is 6. The product of the outer terms, 2 times -2i, is -4i. The product of the inner terms, 3i times 3, is 9i. And then the product of the last terms, 3i times -2i, is -6i squared. Now, really quick, I want to look at -6i squared separately. We know that I squared is -1, so this is going to be -6 times -1. And in the end, that gives us +6. So we can rewrite this expression with that -6i squared as +6. Basically, because an I squared is equal to -1, any term that has an I squared, we just need to change the sign to deal with that I squared. Now that we've done this, we can combine like terms. The real parts, 6 plus 6, give us 12. The imaginary parts, -4i plus 9i, gives us +5i. And we end up with 12 plus 5i in the end. This is more or less what we need to know about complex numbers to move forward. But if you're interested in complex numbers, I would recommend doing a little bit of research online to seeing how they're used and what you can do with them. It's really a fascinating subject, and I would rather you find them to be something interesting than something that's scary. So be brave, look them up online, and learn a little bit more about them.